There we go. Now it says I'm live. Let me double check that, make sure that the audio is working correctly. Um, for those of you that are in here right now, just please tell me if there are any issues. Please tell me if everything is visually good to go or things along those lines, because I haven't used this top-down setup for a while. I used this top-down setup last spring, and like I said, it's been a while since I've done something like that. Let me fix this camera a little bit. There I am. Yeah. I can make myself bigger. I can make myself smaller. It's kind of a nice little setup that I got going on there. Let's close that. Let's open up that. Excellent. Alright. As people are joining, like I said, just please make sure. I want to make sure that I can, or that everything's working properly. So just give me a little thumbs up saying, like, hey, yeah, it's working. I can hear you. I can see you. Things like that. That'd be great. That would warm my heart as people are joining for the next little bit. Shareable link. Paste that there. So just give me a little. Okay. Haha, yes, it's working. I love it so much. Oh, goodness gracious. What a world we are living in. Hopefully I'm not too loud right now. I'm checking my audio levels on OBS Studio. I can actually see that for once. Just kind of nice. Excellent. I see there's like 12 people in here so far. I'm just giving people an opportunity to kind of jump in. There we go. I'm getting some thumbs up right there. There we go. There might be a little delay in me getting the comments versus... Can I toggle timestamps? I thought I could toggle timestamps. There we go. There we go. All right. Okay. So my plan for the remainder of this time that we have is to jump into some of the definitions and information that we need in regards to the next chapter that we're going to be covering. The stuff we did with normal distribution, I'm going to get you feedback on that as soon as I can. But of course, this whole week is just going to be like just weird in general. I know. But my goal is to do intro linear regression in the next chapter to you right now, and then when I see you again on Wednesday, I plan on doing something similar. So we'll see how that goes. And again, I'm really hoping the delay isn't too bad on this, and that people aren't having too much of an issue. Sorry, I'm getting emails about random stuff right now, and I just want to make sure that I'm covering anything. They're talking about vocational school in that email. All right. Excelente. Cool. All right, so let's see here. I'm going to start getting into this. So, and this video, of course, will be saved for anybody who needs it. But today is the 23rd. And this is the beginning of something I like to call scatterplots, associations, if I could actually spell it today, associations, and correlation, comma, comma. There we go. It's all good there. Excellent. Now, like I said, I'm gonna try and not go over my time here, because I really want to make sure that you get to whatever other classes you need to get to. Yeah, but I don't know. Again, this is just gonna be a weird kind of day. And I'm working from home, so I hear my daughter in the next room, and it's a little unnerving. I'm like, that's just okay, cool. So let me just give you some basic background information, because that's all that today is that I'm really focusing on, just background information in regards to this brand new chapter, which actually begins with chapter 6 for the sake of argument, if you wanted to look into that. Am I able to zoom in a little? I don't know if I want to zoom in a little. I'm afraid I'm going to mess with the settings. I'm not going to mess with the settings right now. Okay. Scatterplots. Scatterplots are the thing that you guys have been dealing with for a few years, probably starting back in middle school. Scatterplots are the most common display of data behind or right in front of histograms. I would say that scatterplots are the most common display of data. When it comes to dealing with scatterplots, you need to confirm and make sure, of course, that you are dealing with two quantitative variables. Scatterplots are specifically geared towards quantitative data, not categorical data. So obviously that's something that needs to be made sure of course. When you are given a set of data and they're like, hey, create a scatterplot, and you're like, yeah, but one of them is categorical. That's not going to work for me. Like, yeah, of course, because you can only do this thing. You can only do this thing with quantitative data. Now, what do? They show patterns, trends, and relationships. That's what they do. They show patterns, trends, and relationships. If you're able to graph two sets of data against each other, something may be revealed in the visual image of the scatterplot that may be helpful mathematically, and that we can actually quantify with something, some kind of numerical value. But again, I'll get to that when the time is appropriate. That's a scatterplot, or that's what scatterplots show, really. Now let me talk about the word association. Now you know what the word association is, but let me give you the context of the word association in regards to this chapter. If two variables, I should be writing this down as I'm saying it, if two variables on a scatterplot, come on you, reveal a pattern, then they're associated. Now, I want to be very clear and specific about what I mean by pattern. This pattern does not have to be a linear pattern in order for it to be an association. This pattern could be a quadratic pattern. It could be an exponential pattern. It could be something that just like, oh wow, I can literally see the data following this little path, as you will, or something along those lines. And if that's the case, then yeah, they are associated. The two variables are associated with each other. And that's great. Now, obviously with scatterplots, you guys have been dealing with mainly the idea of linear patterns, which a linear pattern has a more specific definition. So if two variables are just related somehow, reveal some kind of pattern with each other, then you would say the two variables have an association. But there is a specific type of name that we give to a linear association, and that is the word correlation. Now, if I'm talking about correlation, if I'm talking specifically about correlation, then I am talking about a linear association. So I want to be very clear on that. If I use the word correlation, then the automatic assumption is that there is some kind of linear relationship between the two variables. Again, trying to be very clear about that. If I use the word correlation, then automatically you are referring to the linear relationship between the two variables. Now, that linear relationship may not look linear. It may not look linear. It may be like, oh, these two variables clearly have no linear relationship. That's fine. Then we can talk about it having a very weak correlation. Oh yeah, they look like they line up in a straight line. Yes, then we can talk about how strong the correlation is. If you hear the word correlation, I want you to automatically be thinking in terms of it being linear. Like, oh, it looks like they have a quadratic relationship. Okay, that's fine. What's the correlation? Oh, the correlation's very, very weak because it looks like a quadratic. Well, yeah, that's absolutely true. What to look for in a scatter plot? When you see a scatter plot, there are various things that you need to look for in regards to well, I go back to the word cuss. When we talked about cuss in regards to graphical displays, we talked about center and unusual features and shape and spread. There's a similar motivation here when it comes to scatter plots. Number one, you need to be looking for the direction of the data. Where is the data being directed? Is it being directed in the positive direction, the negative direction, um, possibly both? Question mark. Because if you think about a quadratic relationship, if you had a quadratic relationship, then initially the data might be going down, but then after a certain point it starts going back up, something along those lines. You might talk about, okay, the direction of the data, maybe it does have an exponential relationship, so maybe you would describe the direction as, well, it remained flatlined for quite a while, and then all of a sudden it just started skyrocketing upward in the positive direction. That's an explanation of the direction. After you talk about the direction, perhaps you might be able to give it a form. When I say the form, I'm talking like, well, the form might be linear, or the form might be quadratic, or the form might be exponential, etc. The form could be anything. The form can be anything. And mind you, today is all about definitions and vocabulary and things of that nature. We're going to be seeing actual examples of this on Wednesday when I live stream with you guys again. You could also talk to the strength of the correlation. Or I say correlation, but it could be association as well. I mentioned the word strong correlation or weak correlation before. Those are common words or common phrases that are used in regards to describing the strength. But we'll get into those details in a little bit. And of course, you can also talk about outliers. Now, again, with outliers, when you have just a flat out set of data, you could talk about something being an outlier if you actually had the numerical evidence to back it up. Unfortunately, you can't just look at a scatter plot and be like, yep, that right there, that's an outlier. Unfortunately, you can't just do that. You have to have some evidence to back it up. Now, there are different types of procedures that you could go through with a scatter plot in order to determine whether or not something is or is not an outlier. Sometimes, in rare occasions, you can talk about what it looks like, but it has to be very clear that it is an outlier. For example, just for the sake of argument, I'm just going to mime this on the paper. If you had a scatter plot that followed a quadratic pattern, if it had a quadratic form, and the quadratic was absolutely perfect in terms of a scatter plot, but then you had one random point that was like, I don't know, here, then perhaps you could say, well, based on the evidence presented to me, this point seemingly is an outlier. Now again, notice I said seemingly is. Could possibly be. Fluffy language is very important. Again, still, So, okay, good, yes. Now in terms of correlation, as I said up here, if you're talking correlation, you're talking about a linear association. You're talking about a linear association. And in your calculators and maybe what you've done in the past, perhaps you have performed linear regressions in order to correlate the data. And that is exactly what we're going to be doing over the course of this chapter. Before you correlate, you must check conditions. You can't just run a linear regression just for the fun of it and just be like, yeah, I'm going to run a linear regression. Cool, cool, cool. You have to check certain conditions ahead of time. And it's not enough just for you to know, oh, yeah, the conditions were fine. No. When you actually perform these problems on an assessment or the AP test or something along those lines, you actually need to write out these conditions like as a subsection. Like, oh, conditions. I checked this. Yep, I checked this. It was correct. I checked this. They're going to expect that you do these things. Eventually, we're going to get to a point in AP Stat where you do hypothesis testing. And writing out your assumptions and conditions are going to be mandatory. You need to write out your assumptions and your conditions in order to proceed with whatever test that you are running. Now, correlating two variables together, checking the linear association, you need to first check the following conditions. Number one, as I mentioned before, the variables must be quantitative. They must be quantitative. If one of their variables is not quantitative, then you cannot proceed with the linear regression. You can't. Number two is the scatter plot, because of course you can create a scatter plot for any types of quantitative data, but if you're going to continue with a correlation, well, is the scatter plot, quote, straight enough, end quote. Straight enough is a very vague term, and it's a vague term on purpose. If your scatter plot clearly created a quadratic, yeah, that's not straight enough. Now, perhaps it would be in your best interest to run a correlation with the first half of the data and then separately the second half of the data, and then you would be justified in doing that because perhaps the first half of the data looks straight enough and the second half looks straight enough, but they clearly produce two different types of relationships, one negative and one positive. But this is going to be one of your conditions. Is your data straight enough? Is it just an actual scatter plot where the points line up kind of in a straight line? Or is it just one giant blob that looks like a rectangle? Finally, are there any outliers? Now, this is important to identify. Now, of course, we can guess or believe that there might be outliers. I mean, there could be. Oh, that point right there, it looks like it could be an outlier. I've identified it as an outlier. I'm not calling it an outlier. I'm just saying, it could be an outlier. According to the evidence that we have in front of us, all of the data seems to be right here, and then there's like one random point over here. I can call that an outlier if the evidence were obvious enough. Now, if there is something that you believe to be an outlier, and this is one of the few stars that I'm going to give you, I'm by the end of this year, you only might have like a dozen stars written in your notebook, but this is going to be very important. Star. It's a momentous occasion. A good statistician will calculate a regression with and without possible outliers. A good statistician will calculate a regression with and without possible outliers. Now, the reason why I'm spending so much time on this particular start point is because if there is a possible outlier and you think, yeah, this could be an outlier, one definitive way of actually showing numerical evidence for it being an outlier is calculating the regression with and without that data point. Because if something, whether it be the slope of the line of best fit or the variable that I'm about to show you on the next page, then you have numerical evidence to show, yeah, this is an outlier. I ran the regression both with and without, and look what happened as a result to the numbers. That's good evidence right there. Even if you have outliers, you can still run a correlation. You can still run a regression. But you just got to make sure you run it both with and without. That is good practice. Last thing that I want to show you today before I shut this thing down. I want to introduce you to the letter R. Now, I may have verbally or maybe hinted at it. Maybe we've read it down before. But the letter R, the variable R, is going to be very important over the course of this chapter. This is what we are going to refer to as the correlation coefficient. We are going to refer to it as the correlation coefficient. It measures the strength of a linear association. R is going to measure the strength of a linear association. Now, next time, I'm going to show you how we calculate R based on a set of data. Next time, I am going to give you some additional information in regards to what R does, depending on what it is you're asking of it, numerical values of it, things of that nature. But in the meantime, I'm done. It's 8:20. Yay for weird days in school. But I thank you guys for hanging out with us this morning. And I will post a brand new link in the Google Classroom on Wednesday, and we will be here for that time. But yeah, I'm going to sign off. You guys do your thing. Thank you for joining us. I'm going to end that stream. Good night. Morning, whatever.